Hi everybody. In today's session we will be looking at re-ingestion. This is the process whereby alerts that have been captured by the correlation engine needs to be re-ingested for whatever reason. Scenarios where this can occur is anything from an outage on your link that connects to the central platform, so internet outage. It could be a disk that's run full on the Elasticsearch, etc. There are various infrastructural and software related issues that could be contributing factors to this. To determine what your period is that you need to re-ingest for, we will go to the event search component. Now, your data gap may be for today, it may be for a day in the past, so let's go to 7 days. There you can clearly see the gap. Now, on that one, I'm simulating an outage, so basically I deleted a day's index to simulate an Elasticsearch storage that has been filled up before we increase the size, so there's obviously a gap there, and we need to re-ingest the data for that specific period of time. Now, the data is present as long as your collectors and your aggregators were running. The data will be present on them, so they will be re-ingestible, and you can then extract that data and insert it into the platform. As an example, if we want to re-ingest data from 10 a.m. in the morning until 4 p.m. in the afternoon, we will have to adjust the time based on our time zone. So if you expand the events and you look at the pure JSON, you'll see that the timestamp does not necessarily match where the event is indicated on the dashboard. And the reason for that is the web interface is smart enough to adapt the times to the actual time that you're viewing it at. Now, my time zone is GMT +2, which means that the system logs at UTC, which is Universal Time. So I have to deduct 2 hours from everything that I want to see. So in this case, I'm taking it from 10 a.m. So in this example, we're using 10 a.m. to 4 p.m. I've converted it to the timestamp, the format that is acceptable. Please bear in mind that it uses a 24-hour timescale or not a 1 to 12-hour timescale. And I would then have to adjust these to subtract 2 hours from each of them. So if 10 a.m. to 4 p.m. turns into 8 a.m. to 2 p.m., that would then be the time range that I'm working with, and this is very important to do. What I suggest you do is practice with this based on what you've ingested into your environment, etc., and you can then re-ingest while you're doing POC or in your initial testing phase. You can re-ingest data that's already there. Just delete the index and re-ingest it, and this will allow you to get more comfortable with your specific time. So if you're in -5 from UTC, you will need to add 5 hours to the timestamps that you're working with, for example. Now in this case here, if we go and check within the DevTools and we just do a listing of all the indexes, we will see that the 10th is missing, and this plays into the scenario that I've painted where the Elasticsearch volume ran full and it didn't ingest any data on the 10th, etc. It's very rare that you would get that on a precise day. It'll more often happen during the middle of a day or whenever the disk runs full until you discover it. So you will not necessarily work with just 1 day's worth of re-ingestion, but it is very important to make sure that you work only on 1 day at a time and make sure that you cover all the gaps that's in your logging. This will generate duplications, because to prevent duplications you would actually have to match the events one by one to make sure that you don't have a duplicate. And in general, we recommend you just use 1 hour time frames. You can take it down to the second or even the millisecond, but again, that will extensively increase the time you need to do this. So for here, we're going to jump into the bash or the shell for the central environment. And the path will always be the same. It doesn't matter which entity or endpoint for the correlation engine you jump to, the path is always the same within the container or the pod. And it's bar OSX logs alerts, and you'll see that there are years for which you have logs. And the primary log file is alerts.json. Now that's the one that we'll be working with. So in 2023, you'll see there's months. You go to the month that you want to address, and if you do a listing, you will see the data for the 10th is there, and it will be denoted by the 10 in the file name, and you're looking for the gzip file. Don't worry about the fact that the gzip file is compressed. You can extract the data directly from it into another text file that you can use for the re-ingestion, which is the process that I'm going to show you now. And you do not have to uncompress or decompress it first. The important thing here is that you never work on the original, you always make a duplicate. And the suggestion is to just step up one level in the folder structure, because that's still within the volume mapping, to ensure that you have sufficient disk space. Now that we have copied our file, we will split the screen. You can use multiple screens or separate. If you use, for example, PuTTY, you can just do duplicate connections, etc., and so on. And we will connect with that into the environment as well. And the reason you're doing this is to keep track of disk. So if you look at df-h, you can see that the bulk of your storage is allocated to that mount part. And you will keep an eye on the size of that, because especially if you have larger flows, if you extract the data, you're going to extract it to an intermediary file first, and then you're going to copy it across into the alerts.json file, which means you need significantly more storage capacity. Say, for example, you have a gig worth of data that you're extracting from the gzip file. You would extract that into a separate file, that is 1 gig, and you would then cut that over into the alerts.json file, which would then generate another gig. So you have a copy of the gzip, which takes up storage. You have a copy for the intermediary file, which takes up 1 gig. And then you have an additional 1 gig that you've pushed through to the alerts.json for re-ingestion. So that's at least 2.2, 2.3, 2.4 gigs that you're working with there. If you're working in high flow environments where your compressed files are like 10 gigs, and you copy those and you extract those, you're looking at hundreds of gigs to work with. So it's important to make sure that you have enough storage allocated to the mount points relevant to where the data function is going to be performed. Now, to watch this continuously, to make sure what sizes you've got to work with, and if you may be limited in funds and you can't expand the volumes exponentially, and you're working with large volumes of data, you may have to split the recovery over multiple days to wait for the alerts.json file to roll over into a fresh one and the previous one being compressed. So that's why we work with chunks of up to a day of re-ingestion, but you can make that down to an hour if you want to. So there's a nice command called watch. And what we will do is we will specify that we want to refresh this command every 3 seconds. And we can put that into inverted quotes or single quotes, depending on what your options are that you're wanting to do. You can use multiple commands at the same time. If you do that, though, I would recommend using single quotes, because obviously you're going to use operators, etc., and so on. So in this case, we're just going to keep an eye on the storage. So you run that. To get out of that, you just press Control-C and you can go back into it. So let's step up one layer to the file that we were looking at. And you can see there that OSSEC alerts 10 is there. But we don't want to decompress it because that's just going to take up unnecessary storage, etc. We just need to know what the actual syntax is that we're going to be filtering the data for. So what you can do is you can run the head command. You just want the first line, just one line, of the var OSSEC logs alerts.json. And that will give you the first event in that file. And what you do is you copy that portion there. Now, obviously, that's from the 14th, but we'll adjust that shortly. So what you do is, okay, we've got that now. What I recommend is that you use something like Notepad++, etc., and you paste that in there. So in this case, we are working with the 10th, and we want all data that's for the 8th. So if you're looking, or for 8 a.m. on the 10th. So if you're looking for just 1 hour, this would be perfectly fine because it will take everything that matches up to that point and it will do what you tell it to do, as you can see from the command example that I'm going to show you shortly. So we copy that and we do zgrep. So zgrep is the same as grep. If you're not familiar with these commands, feel free to use the Linux man pages or Google them, etc. They are extremely powerful. Now zgrep is just like grep. The only difference is it can read inside archives. And what you do then is you do a single quote. You paste what you've just copied or from the Notepad++ or whatever it is that you've chosen to do, and you tell it which file to look inside of. So the sequence is important. First you tell it what to look for, then you tell it where to look for it. And then what you do is you pipe it out to, say, re-ingest.json, and you let it run. If you want to be really fancy, you can always do something like logs, alerts, and then 2023. And you can see that there's the file there. And when we run this now, it will show you that it's created a new file. Now, we're dealing with really small sizes here. This gets much slower the bigger the files, etc., and so on. So that's just something to be aware of. Now, if you look at re-ingest.json, you can see it's 13 kilobytes and it's not compressed. So what you can do now is you can do a head -n re-ingest.json, and you can see, okay, the timestamp is okay. That's perfect. And you can do a tail -n1, which takes the last line. Now, what we're looking for is nothing to exceed 0.8 in that case. So we run that again, and we can see, fine, that's within our parameters. So we've now extracted that. Something to bear in mind is sometimes the logs can actually have a matching item inside the log. As you get more comfortable, well, not just inside the log, because these are inside the logs. So it'll have a duplicate. So say, for example, there's a log that's got a full log value still being present, which means it's got the raw log just in a field called full log in the event. So that timestamp may not be matching the one that you're searching for, but it is matching the one inside the full log. It's rare, but it does happen. In cases like that, you will have to refine the re-ingest.json file, for example, further once you've done the initial extraction. Now, where that is important is to keep your data hygiene well. Now, in certain cases where you do get that, you would filter that out by using a removal feature for grep. So you can, because this is no longer in a gzip file, you can just use normal grep, and you can use the -v operator, which will then remove whatever it matches. So if you see that that field is repeated, but say, for example, there's a special character somewhere here that you can anchor onto. So say, for example, there's a backslash at the front. You can then use that as additional criteria to filter that out. Those advanced Linux utilities and command line operations is beyond the scope of this session, so I would highly recommend going and playing around with grep, tail and head, etc., to become more familiar with those. Right, so now the important part is we've just extracted 8, but we want to do 9, 10, 11, 12, 1, and 2. But why would we run it all over and over and over and do them 1 hour at a time? This is where the power of Linux really shines. So we're going to remove the re-ingest.json, and you can see it disappeared on the right hand side, and we're just going to press up to where we did the original zgrep. Now what we can do here is you copy that piece and you go to where the single quote is, and you add a backslash and a pipe, and you paste that in there, and you change that 8 to a 9, and you keep repeating that process until you get to the time that you want. And what this does is it use those as OR operators, so it will match on any of those, and it will output it to the re-ingest.json. So we're going to do 12. We're going to do 13. And we're going to do 14. Now, what you can see here is that we're in on 14, so that's 2 o'clock UTC time. In my time zone, that will be 4 o'clock. So this matches the discussion we had earlier. Now, if I run this, it'll create the re-ingest.json again. You can see it's significantly larger in size. So we can do head minus n1 re-ingest.json again. And we can confirm that the timestamp is correct. And we can do tail minus n1. re-ingest.json, and we can see the end time is correct. So what you will note is that we wanted it up to 2 p.m. We didn't want it to go beyond. Now I did this on purpose so that you can see how easy it is to make a mistake. What you need to do is, if you need it up to 2, your filter for your re-ingest should just run up to 1, because the 1, or 13 in this case, because it's a 24-hour clock, will run up to 13:59 if there are events present for that time. So it will be up to 2 o'clock. And you don't actually want to include 2 o'clock, because then you're going to create too many duplicates. I hope that makes sense. So we're going to remove the re-ingest.json again. Clear the screen, make it a bit easier to read. And we go back up. And what we do is we just remove the last backslash pipe and everything that follows it up until the single quote. So we get to the 13. And we run this, and we can see now it's smaller. It was 82 kilobytes, I think, and now it's just 74. And you can verify that in this case it is now correct. Now that you've extracted your data, you can see there 1345. So you're still within the parameters that you've set. So now that you've extracted the data, the next step is to cat that file. And it's important to use the double, not the single, because if you do the single, it'll wipe out what's already in the alerts.json. If you use a double, it appends it to the end. Very, very important. because if you interrupt the alerts.json or you wipe it out, you're actually losing data that may not have been re-ingested yet, and there's no way to recover from that. So be very careful. Now, what you do is you cat that, select logs, alerts, alerts.json, and you just press enter. And what it does is it appends what you've just set to re-ingest, and it writes it to the alerts.json. Now, the important part. When it re-ingests it, it will write it in Elasticsearch to today's index. For auditing purposes, it is very important, if you do re-ingestions like this, to make a note of that so that when you get audited and it's from an index that needs to be archived, you actually know which index contains the data for this date. That is just a professional courtesy that I'm extending to you, because this will occur. If you're in a compliance-based industry, you will be required to restore backup data from a specific index. Now, if the auditor comes and he says, I want the data from the 10th, and there's no index for the 10th, so what are you going to restore? It's going to be in the index for today, which is the 14th. So you need to note the data where it's located in the index. If you haven't done any re-ingestion, you have nothing to worry about. It will be on the day of the index. But if you have done re-ingestion, keep track of those for auditing purposes. Now, we don't just need that that amount of data, because I deleted the index for the 10th. So what we'll do is I'm going to unzip that file and just completely transfer it into the alerts.json. So when you have a full day, it's much simpler. We're going to remove the re-ingest because we're not going to use that. Sorry for the keyboard malfunction. So we are just going to take that file, and then we're going to cat it into var osec logs alerts.json using the double redirects. And obviously I have to fix spelling on the left, but let's just quickly take this up one level so that we can track that folder where the alerts.json sits, so that we can see what size it gets to. We're taking out the human readable format so that we can keep track of the size down to the byte level. Let's quickly fix that spelling mistake. And there you go. Now you can see the file jumped spectacularly in size, and it is re-ingesting. Now the next thing that's very important to watch is your events processor. Now, with smaller events like the ones that we're working with now, it's not that big a deal. It'll be processed very quickly. When we log in, you can see it's already done processing. Now, when you work with large volumes of data, the queues will fill up, and it will seem like there's red lines below the queues, etc. and so on. Don't worry about that. That's quite normal. It will continue to process properly, but keep an eye on this. If at any point you see error messages popping up in the right hand corner of any of the processors, stop the put Elasticsearch HTTP to ensure that you don't lose any of the data that you're ingesting, because finding those individual items is very, very difficult when you do the extraction from the command line. Now, what you can do here is you can just keep an eye on it, etc. It'll flow. If you have large volumes of data, you may want to consider splitting the data into 1 hour population groups at a time, so that you push that through 1 hour at a time, because of the fact that when it fills up the queues, it also delays your current ingestion that's taking place for current events. So say for example you're re-ingesting 100 gigs, but it's going to take you 14 hours to do that. It will basically mean that your flow will lag behind by 14 hours. And it will have a gap at the end there, which puts you in a bad space, because it doesn't necessarily alert you with your alerts when they're ingested at that specific point in time. So you may want to do smaller chunks at a time. If you're not too concerned about that, you can do it all in one shot and just let it finish. You're more than welcome to do that as well. It is just a general guideline. You can also contact us under your support package to make slight alterations to support for higher throughputs, etc. The system is completely customizable. Now that we're checking the 7 days again, you'll see that there is data there, but it's not nearly as bulky or as much as the others. Now, this specific implementation has 3 log aggregators as well as the central. I've just re-ingested the central. Whatever you do on one, you need to do on all of them, because all of them contain the source files for the events that have been correlated. So you would need to connect to each of the log aggregators and rerun the same commands and go through the same process. The more log aggregators you have, the longer this process will obviously take. So that's just a heads up. Once you're done, there should be a very clear indication of which ones are missing. Now, if we check the indexes again, you'll notice that the 10th is still missing. And the reason for that is very, very logical. We haven't created the index for the 10th. As stated previously, it would have been ingested under today's index. So this is why you need to keep track of where you did re-ingestion, so that if you need to restore from backups, you know which indexes you need to restore for what time periods, etc. and so on. I hope that you found the session helpful and that you learned a few things. I would definitely recommend playing around with the command line tools on Linux a bit more. They're extremely powerful, especially when it comes to processing large volumes of data. You have access to your own instances with their alerts.json and their compressed files. Play with them. There's nothing that can go wrong, especially in the POC time. Have a great day further.